So I'm Nicolas Stevens. I just got my PhD in engineering in applied mathematics, which I have undertaken at the Center for Operation Research and Econometrics in UCLouvain under the supervision of Anthony Papavasiliou and Bert Williams. So during the last 4 years of my PhD, my research has been focused on the electricity market. So electricity is a very important sector of our economies. It's a paramount input for most of our industries, and more generally a good that we use every day for many different applications. Since the late 90s, the electricity sector has been liberalized in most Western countries, such as in the US or in Europe. This means that the significant level of coordination that is needed in order for the electricity to be delivered at home to the end consumer is now achieved by a market. That is that the coordination between the suppliers who produce the electricity, the consumers who ultimately consume the electricity, and the system operator who transport this electricity, all the coordination between these different actors of the supply chain of electricity is now the outcome of one market. The electricity market has occasionally been in the spotlight in the past recent years. For instance, after the Russian invasion of Ukraine in 2022 and the gas crisis that followed, which led to electricity price who soared up in some European countries, sometimes to 4 or 5 times the usual preceding levels. This led the public opinion to question how the electricity market works and whether it works well. In my research, I mainly focus on one particular feature of these electricity markets, namely how to deal with the non-convexities that are present in the market. Electricity markets are indeed typically organized in a highly centralized fashion, relying on sealed bid uniform price auctions. These auctions typically include non-convex bids. An example of what we call in mathematics a non-convexity is, for example, when a power plant, instead of being fully flexible and able to produce anything between, say, 0 and 500 megawatts, is only able to produce either 0 or 500, but nothing in between. This is when there are some indivisibilities in the production processes. In practice, these types of non-convexities are encountered in most electricity markets around the globe. The main implication of these non-convexities is that they impede the existence of a uniform market clearing price. To put it merely, supply and demand curves fail to intersect, and so there is no market equilibrium. The classic marginal pricing rule failed to lead to an efficient allocation of resources. Therefore, how an auctioneer should deal with this issue and what the electricity price should be under these settings is an open question which has attracted the interest of both academics and practitioners over the past 30 years. Among others, 2 contributions of my thesis aim at understanding better one particular solution that has been proposed to the aforementioned problem and which has been called convex subpricing. In the first contribution, published in Energy Economics, I analyzed the economical properties of this pricing method. I built a mathematical model to understand its impact on the market participants and to analyze some trade-offs with some other possible solutions to this problem. The conclusions of our paper highlight several advantages of these convex prices. Computing these prices is, however, a complicated mathematical problem. Therefore, in a second contribution published in IEEE Transactions on Power Systems, I developed an algorithm that is able to compute these so-called convex prices. We show that our algorithm, that is about 5 times faster than the state-of-the-art in the literature, is able to compute these prices on realistic auction datasets, which makes it a feasible solution for realistic electricity markets. In the near future, I intend to continue my research on the electricity markets with a postdoctoral position at the University of Cologne at the Max Planck Institute for Research on Collective Goods. Thanks for watching.